So here in our first example, 4x squared subtracting 81. So it's already in standard form. There is no greatest common factor. But I notice I am subtracting two squares. What are those squares? Well, 2x squares to make 4x squared, and 9 squares to make 81. So now you look at this as your A and your B that are being squared in this difference of squares. So a squared minus b squared, 2x squared minus 9 squared is going to factor to be 2x minus 9 multiplied by 2x plus 9. And then we check out these two binomials. They cannot factor anymore, so we're done. Now, looking at number 2, the first issue I see is that it's not in standard form. Let's put it in standard form first. Negative 9x to the 6th plus 100. Now that it's in standard form, I need to factor out a GCF if it has one. Since my leading coefficient is negative, I'm going to factor out a -1 greatest common factor. And that's going to leave 9x to the 6th minus 100 now. So now that I've factored out my negative leading coefficient, I can look at what's left over and recognize what squares are being subtracted. So this is what squared subtracting what being squared. Well, here I know 3 squared makes 9, and x to the 3rd squared makes 6 because we multiply those exponents. And we know that 10 squared is 100. So now this is my A and my B for my difference of squares pattern. So -1 GCF stays in front. 3x cubed minus 10, 3x cubed plus 10. So I just want to point out that this step here and this step here, you can skip and do that in your mind. It's up to you.